Okay, hello everyone. So this is Rolle's theorem. I'm not sure how important it is on the AP Calc, ABBC exam, but probably not that important, and that's why I put bruh. Okay, so here's the complicated explanation that AP goes by. Let f be continuous on the closed interval AB and differentiable on the open interval AB. If f of A equals f of B, then there exists at least one number C in AB, such that f prime of C equals 0. Okay, so basically it's saying if I take two random x values, for example, if I took, um, like here, -2 and 2, let's just say that this is like f of x equals x squared. If I took two random points on some interval and the y values are the same, so in this case, both y values are 4, then what that means is that there exists one number, at least one number, in this interval range from 2 to -2, such that the derivative is 0. And if you look at this graph, you can just see that that derivative point where it's 0 is right here at the origin, because this is just f of x equals x squared. Okay, so now we will do some practice problems with the Rolle's theorem. Okay, so part A, part B, and part C. If you have a time, just pause. Okay, boom. Okay, now we're back. Part A, x squared, f of x equals x squared minus 5x plus 4 on 1, 4. Okay, what is the problem 1? Decide if Rolle's theorem applies, and if so, find C and all A, B that satisfy it. Okay, so for part A, what we basically do is we just find the y values of the endpoints. So just plug in 4 into our function and 1 into our function, and if they're the same, then we're good. Okay, so 4 squared minus 5, oh my god, minus 5, 4 times 4 plus 4, what is that? Oh, 16 minus 20, that's -4, plus 4 is 0. Okay, so now let's try 1 squared minus 5, 1 plus 4. 1 minus 5 is -4 plus 4 is 0. Wow, when you look at that, 0 is apparently the same as 0. Okay, what does this mean? That Rolle's theorem applies. So boom, Rolle's theorem applies. Okay, so what does this tell us? Well, Rolle's theorem states that if or two random points have the same y values, that means that there is some f prime of c, where c is just an arbitrary integer value, is 0. And we can in fact find that by finding the derivative of a function. So our derivative is clearly just 2x minus 5. And how would you find where the derivative is 0? Well, basically, we just set it equal to 0. And solving this, we get x equals to 5 halves, which we can, if you want to go over the top, confirm with a number line, as we saw in our relative max and min video. So we just pull out 5 halves, that's like 2.5, so I can put a point at like, I don't know, 6, and another point at 0. Okay, plug in 0 into our function, 0 minus 5 times 0, so 4, so that's positive over here. Oh wait, sorry, I plug it into our derivative, yeah. So 0 minus 5, -5, so negative over here. By the way, I plug it into the derivative because Rolle's theorem basically says f prime of c equals to 0, and we want to see where the derivative changes from positive, or from negative to positive, or positive to negative. Okay, so with that out of the way, let's plug in 6, and you clearly get a positive value. So that proves that not only do we satisfy Rolle's theorem, but we can prove that we have a relative min, because it goes from negative to positive. Okay, I spent too much time on that problem. Let's go on B. Find the two x-intercepts of the function f of x equals x times x minus 3, then show that f prime of x equals 0 at some point between two x-intercepts. Okay, so what is it saying? It's basically just a fancy way of saying do Rolle's theorem. And basically, we're being asked to find the two x-intercepts of the function first. Okay, so how do we do that? Well, basically we have a function, so we can clearly tell where x-intercepts are x equals 3 and x equals 0. Okay, now it wants us to basically do Rolle's theorem. Okay, so we can essentially just take our derivative. So if f of x equals, and I'm just expanding this, x squared minus 3x, what is the derivative? So bring the 2 down, make that exponent 1, 2x, bring the 1 down and make it 0, minus 3, that's our derivative, right? Solving for this by setting it equal to 0, we get x equals 3 halves, which means that at x equals 3 halves, or derivative is 0, which is in fact between the two x-intercepts. Okay, finally. This might be a bit tricky for some people, but it's literally just the same thing that we've done before. So basically, do Rolle's theorem. Okay, so let's plug in our exponents. Plug in 2, we get 1 minus the absolute value of 2 minus 1, which is 1 minus 1, which is 0. Plug in 0. 1 minus 0 minus 1, negative 1 becomes 1, 1 minus 1 is 0. Oh, what do you look at that? 0 equals 0. Insane. Okay, so now that we know f of 0 equals 0 and f of 2 equals 0, we could, everything might seem all fine and well, right? Because we're like, oh, the two zeros, yay, Rolle's theorem applies. Well, if you actually graph this by using some of your algebra 2 skills, or just plugging in points, if we plug in 0, for example, we get 0. If we plug in 1, we get 1. And if we plug in 2, we get 0. So our graph kind of looks like this. We can see that it is not differentiable because we have a cusp here. So because it's not differentiable, Rolle's does not apply. So you have to be careful with Rolle's, because it does state that you do have to kind of know the complicated explanation, because it has to be continuous and it has to be differentiable. So these are two very key things that you have to make sure that you do completely right when you're talking about Rolle's theorem. Okay.